There's a number on your electric bill that you have simply accepted as the cost of surviving summer. You open it, you wince, you pay it, and then you wait for next month to do it all over again. Somewhere between May and September, that number quietly becomes one of the largest expenses in your household, and almost nobody stops to ask whether it has to be that way at all. Because sitting on top of your house, right above the room where you sleep and eat and raise your family, is a pocket of superheated air that your cooling system spends every single day fighting against. Not winning against, fighting. Your air conditioner is not cooling your home. It is losing a slow war against a heat source you probably never think about. And the solution to that war has been sitting in hardware catalogs for the better part of a century, costs less than a decent dinner out, and requires no electrician, no contractor, and no permission from anyone. The question is not how to pay the bill. It is why nobody ever told you there was another way. If you are new here, this channel is Next Reveal. We dig into knowledge that has been documented, tested, and quietly left on the shelf while more expensive alternatives took its place. Subscribe before this video ends, because what comes next is going to make you look at your home in a completely different way. Now, let us talk about what is actually happening above your ceiling right now. Most people think of an attic as an empty, useless space. But on a summer afternoon, when the sun has been beating on your roof for 6 or 7 hours, the air trapped inside that attic can reach temperatures between 130 and 150 degrees Fahrenheit. The shingle surface itself can crack 160 degrees. That is hotter than many industrial ovens. And between that superheated air and your bedroom ceiling, there's typically nothing but a few inches of insulation and a sheet of drywall. The heat radiates downward through the ceiling surface. It warms every room on the upper floor. It raises the baseline temperature of the entire living space before your air conditioner ever switches on. So when your thermostat calls for cooling, the system is not starting from a neutral position. It is starting from behind. It cycles longer than it should. It pulls more electricity than the manufacturer ever assumed. And it wears out faster than it would if the attic above it were simply cooler. You have been sold cooling solutions from the bottom up. Lower thermostat settings, higher efficiency ratings, smart controls. But the heat pressing down from above has been treated as a fixed and unavoidable condition. It is not fixed. It is not unavoidable. Heat rises. Given a path to escape from the highest point of a structure, it will take it. Given a low-pressure zone to pull toward, it will move faster. If you simultaneously open a cool air intake at the lowest point, you create a continuous thermal column that flushes warm air out and draws cooler air in without a single watt of grid electricity. Engineers call this stack effect ventilation. Builders in hot climates have used versions of it for thousands of years. The windcatcher towers of ancient Persia, still standing in cities like Yazd, Iran, were passive air management systems built into the architecture itself. The device at the center of this story is almost absurdly simple. It is a spinning turbine vent, a domed aluminum cap with curved vanes that catch even the lightest breeze and convert that motion into rotation. No motor, no electricity, no refrigerant. The wind does the work for free. And on days when wind is insufficient, the temperature difference between the superheated attic air and the cooler outdoor air creates its own draft. On a 95-degree afternoon when your attic is sitting at 140 degrees, that difference is enormous. The physics will always find the path. Your job is simply to provide it. The device costs approximately $30 at any hardware store. It installs in a single cut through the roof deck at the highest point of the structure, seals with standard roofing cement, and from that moment forward, asks nothing of you except one annual drop of oil on the bearing. But a turbine vent alone misses the second half of the system entirely. Stack effect ventilation is a circuit. Air leaves at the top. Air must enter at the bottom. Close either end, and performance drops significantly. The traditional intake is a soffit vent at the lowest point of the attic, ideally on the north-facing side, because the north side receives the least direct solar exposure. That temperature difference between entering air and trapped attic air is what drives the draft. Want to turn your setup from decent to totally amazing? Just grab a $60 solar fan and mount it right at the vent. Connect it to a thermostat that kicks in at 100 degrees. It's seriously a total game changer, right? When the attic reaches that threshold, the fan activates and intake flow accelerates. When the attic cools below 80 degrees, the fan shuts off. The solar panel powers the fan from the same sunlight heating the attic. The system is self-regulating, self-powering, and requires no connection to your home's electrical panel. Research from Oak Ridge National Laboratory and the Florida Solar Energy Center documented cooling energy reductions, ranging from meaningful in mild climates to dramatic in hot ones. These are not fringe findings. They are peer-reviewed outcomes from federal research institutions whose work is publicly available. The third component is radiant barrier foil. Heat enters your attic in two forms. Convective heat is carried by the air itself. Radiant heat is electromagnetic radiation from the hot roof surface that travels through air and heats whatever it strikes, including the top of your insulation. Ventilation addresses convective heat. It does not address radiant heat. Radiant barrier foil, a perforated reflective aluminum sheet stapled to the underside of the roof rafters, reflects radiant heat back upward before it can strike the insulation surface. The combination of turbine ventilation, intake airflow, and radiant barrier creates a system where the attic temperature, rather than sitting 60 or 70 degrees above ambient outdoor temperature, falls to within 15 or 20 degrees of it. The workload on your air conditioner falls in direct proportion: a $30 turbine, a $60 solar fan, a $4 thermostat, a $30 roll of radiant barrier foil. Total materials, under $130. Total installation, a single day's work. Total grid electricity consumed, 0 kilowatt hours. From the 1950s through the mid-1980s, turbine ventilators were common on American rooflines. Then, across the late 1980s and 1990s, installation rates began declining. By the early 2000s, they had effectively disappeared from suburban homes, not because a superior technology replaced them. It happened because homeowners associations began treating visible rooftop hardware as an eyesore. Builders stopped specifying them to avoid friction with buyers. Building codes evolved toward mechanical ventilation that created ongoing electrical consumption rather than passive systems that did not. An entire generation of homes was constructed with attics designed to accumulate and hold heat, and with cooling systems priced on the assumption that those attics would always be hot. The knowledge did not disappear from scientific literature. Oak Ridge has continued publishing research. The Department of Energy maintains guidance on it. It simply stopped being built into homes. The same stack effect physics can extend through the entire vertical structure of a two-story home. If the attic is the exhaust point and the lowest level becomes the intake point, the entire interior volume becomes part of the thermal column. Interior doors left open, the staircase functioning as an unobstructed vertical channel, a connection between the living space and the attic draft. Hot air that accumulates at ceiling level rises through the open stairwell, enters the attic, and exits through the turbine. Cooler air from below pulls in behind it. The entire interior cycles. This is the documented operating principle behind centuries of vernacular architecture in hot climates across the American South, the Mediterranean, and South Asia. Here is the honest summary. If your attic does not have a turbine ventilator at its highest point connected to an adequate low intake, your air conditioner is working significantly harder than it needs to, your electric bills are higher than they need to be, and your cooling system is aging faster than it should. That condition is correctable this weekend for less than the cost of a single month's cooling bill. The correction is permanent, maintenance-free, and backed by decades of documented research. The equipment is on the hardware store shelf right now. It has been there the entire time. The knowledge of how to deploy it correctly as a complete system rather than an isolated component is what has been missing. Now you have it. The heat above your ceiling has never had to be your problem. The physics was always on your side. The only thing required was knowing which $30 to spend and where to put it. Not complicated, not expensive, not experimental. Just quietly set aside while the meters kept running.